intermediate college course, that grade can come up. So like if you have a B in there right now and you do well for the rest of the semester and you wind up with an A in the college algebra course, you'll also wind up with an A in the intermediate course, but it can't go down. So if you have a B in that part of the course, then it can't, that part of the course cannot go down. However, some of y'all are not passing at all. And in that case, at this point, it's not looking so good. So I would recommend that you plan to take the alternate final. And if you are, all of y'all have gotten an email from me if you are in that questionable category. So please let me know when a good time to discuss this would be. It cannot hurt you to do that for sure. Okay, so let's go ahead and get started on the Kahoot. Again, as always, please try to participate. If you cannot get on, at least make sure that you are following along. And if you are on, I will give extra credit on homework. This Kahoot is just kind of to review and see how much you've retained from the lecture. So it is new material, but hopefully you've watched the video, so you'll be able to recognize what we're talking about. Okay, if you haven't joined, please join if you can, and if you can't, just follow along. Would this be classified as even, odd, or neither? Okay, good. Let's talk about this. This is actually super easy to tell. If you look at this, 5x to the fourth plus 3x squared, and this would be like 4x to the 0. So if the constant is always like an x to the 0, if you look at those exponents, even exponent, even exponent, even exponent. If that's the case, if the function has all even exponents, then it's even. Okay, and if it's got a constant on the end, that's considered even because it's like an x to the 0. So if the function has all even exponents, it's going to be even. If it has all odd exponents, it will be odd. And if it's got a mixture, then it's going to be neither. Even, odd, or neither. Okay. Look at this. So 3x to the third, the exponent is a 3. 5 times x, the exponent here is a 1. And then anytime you have a constant, it's like an x to the 0 power. So constant is always considered even. So here we have odd, odd, even. And if there's a mix in the problem, it's going to be neither. Which of these is odd? I put an odd person in there because I thought I was being funny. Okay, so it would be red. Let's look at these. Notice that 6x to the third minus 2x, that's like 2x to the first. We're only looking at exponents when we're talking about even and odd. So that's an odd exponent, that's an odd exponent. So the red is definitely odd. Let's look at the one that some of y'all chose, this f of x equals 3x to the fifth minus x to the third plus 7. Remember, the constant is like it's being multiplied by x to the 0. Constant always counts as even. So we're only looking at the exponents. It has nothing to do with the coefficient, whether the equation is even or odd. So it definitely would be the red because this one has a mix, odd, odd, even. So it would be neither even nor odd. Which of these is even? Good. Most of y'all got that. Okay. So if we look at f of x equals 7x, negative 7x to the fourth minus x squared plus 3. And we're looking at just the exponents. A constant always counts as even because that's like 3x to the 0. So here we have even exponent, even exponent, even exponent. So that is even. The blue one is f of x equals negative 3x to the fifth minus x to the third plus 7. So this would be odd, this would be odd, and this would be even. So this one is neither. Now we're looking at the graphs. Would this one be even, odd, or neither?
I have a question, Miss Lisa.
Sure.
So from what I remember about all this stuff, especially from pre-cal, if the graph or the parabola mirrors itself, it's even, right?
That's right.
But because I remember like my teacher back then, like
if it mirrors itself over the y-axis, okay, because a parabola is always symmetric around some vertical line.
So it's odd if it crosses the x-axis, but if it crosses
not
the
necessarily. We'll look at that though in a minute. But you're remembering right, I think, Chris.
All right.
Okay, so like Chris was saying, if you notice this one, if you were to fold this graph over the y-axis, it would come back on itself exactly. So if a graph is symmetric with respect to the y-axis, then it is even. Okay, so even functions usually look like u's or w's or anything that's going to be, and this could have been shifted up or down. If you fold it over the y-axis and it comes back on top of itself, then it would be even.
So I noticed all the symbolic examples that you gave were polynomials, but they don't have to be polynomials. It can be other functions too.
True.
Yeah, like cosines and sine functions, we call those odds and evens.
Absolutely, that's true.
And I'm trying to think of what else, like absolute value, right?
Yep.
Yeah.
That is true.
So
but in this course we're only doing polynomials, right? We'll do some square roots, but yeah,
I think so. I think you can use that trick with looking at the exponent. But yeah, that trick with looking at the exponent only works if you get polynomials.
Well, it'll work if you have square roots or absolute values too. It won't necessarily work.
Absolute values won't work because you can have y equals absolute value of x to the first, and that is an even function.
That's true.
Yes.
That's true.
So you have to know how to plug in a negative x into your
That is very true.
And see whether it like spits
so
it back
we'll talk
out.
about that too. That is true. It works only if you've got polynomials, or that's true. And since we're working primarily with polynomials, that's what I was thinking.
Yeah.
But there are some, yeah, there are many functions.
Yeah, I mean, and for this class, what you're saying is probably like absolutely like correct, right?
Yeah.
We're not doing anything that hard in this class, but if they get to other stuff, then at least I'll have seen.
Yes, absolutely. Don't just go. Yeah. Don't say my algebra teacher told me this works every single time. I'm really glad you brought that up, Matt, because I was really just thinking about what we're working on like right now. So, but if you get to another course, you probably will have to substitute in for your x and negative and see what happens to the signs. If they alternate, then it's going to be odd. If they stay the same, then it's going to be even. And if you have a mix, then it will be neither.
And I did a few examples in the notes like that. So
Okay,
they should have a few examples. And we can also think of the symmetries as like flips of the graph. We're like flipping the graph and it's remaining the same thing. So we did graph transformations, and I explained a little bit with that in the notes too.
Cool. Yeah. Good. Yeah, thanks for pointing that out. That's absolutely true. Okay, so where were we? Okay, classify this graph as even, odd, or neither. Okay, this one is neither, and this is kind of tricky. If you picked odd, it kind of has a shape of an odd function for sure. But if you look at this, odd functions, polynomial functions, will always pass through the origin, okay? So this one has a shape of an odd function, but it does not pass through the origin. So it is not. Well, that's not, yeah, that's true. I think that's true, Matt. Is that true? I'm thinking of like rational functions. That's not true for.
Yeah, all odd functions should pass through your origin because you have to flip
all,
it about.
all odd
You have to flip it
polynomial
about
functions.
the origin, so there has to be something like kind of going through the origin.
Right.
'Cause
I was thinking though, the exception would be like, let's see if I can get this onto my.
Because like if you think about this, the problem with this is like you're above the axis. So when you go to flip it about the x-axis, it's going to end up putting it like on the bottom or something, right? It's not going to end up with the original picture that you have.
Right.
Yeah.
But then if you've got a function like this, for example, it wouldn't work. So like y equals 1 over x. This is an odd function, but it doesn't pass through the origin. So but if it's a polynomial, it will for sure. Okay, so if this had been shifted down, oops, then it would have, and it passed through the origin, it would have been odd. Even, odd, or neither. Good, most of you have got that. So notice that this is kind of an S shape. If you were to rotate it 180 degrees, it would come right back on top of itself. If you look at the coordinates, like here, this is -4, 0, and this is 4, 0. If the X value and its opposite both are paired with the same Y value, then it's going to be odd. And it also has to go through 0, 0. Even, odd, or neither. Here I've given you a set of ordered pairs. Sometimes it helps to plot the points if you can't see them. If you can't see it. Okay, so let's look at this. Okay, first of all, I just want you to notice something here. If you notice that here, -2 is paired with -3. +2 is also paired with -3. -1 is paired with 3. +1 is also paired with 3. 0 can actually be paired with anything if it's an even function, which this is. You can automatically scratch out that it's an odd function, because for it to be an odd function, this would have to be 0, 0, right? Because an odd function has to pass through the origin almost always. So this is going to be even if you look, these two match, the -3 and the -3, and the 3 and the 3 both match. If you were to graph these points, this is what they would look like. Here's -2, -3, -1, -3, 0, 4, 1, 3, 2, -3. Now, this is just a table, so this is these are discrete points. But if you were actually graphing like an equation, you would probably connect those points, and it would look like something like this. So you can tell that that is an even function. So like I said, sometimes if you're really not sure, graph them and see what happens. See if they're symmetric with respect to the y-axis, or if they are symmetric with respect to the origin. So a lot of y'all picked neither, but hopefully that explanation helped. Even, odd, or neither. Notice this time that here we have a -3 paired with a -2x, and here we have a 3 paired with the 2. So if you look at the opposite extremes, here we have a 3 and a -3, and here we have a 0, 4. Okay, so let's look at this. And again, if you picked that it was odd, which some of y'all did, I'll show you why it's not odd. Remember, for it to be odd, it has to pass through 0, 0. So that's why this one's not odd. Otherwise, it would be. If this had been a 0, this would be odd. Assume that f is odd, fill in the missing values in the order they would appear. Okay, good. So if you picked the red one, if this is an odd function, 0 would be paired, 0 has to be paired with 0 if it's odd. So the red one wouldn't work for that reason, because there's a 1 in that spot where the 0 should be. Otherwise, it would have worked. This time we're assuming it's even. And I filled in the 0 because if it's even, 0 can be paired with anything. It doesn't matter. Okay, so let's look at this since. So we want this to be even. So if it's even, that means that these two will, the y values will match. So this would be a 9. And here also the y values should match. And these should, so this should be a 5. So if it's even, so did I do the wrong thing? No, yeah, I did wrong. Gotta watch me sometimes when I put these things together. So it should be, so if you got it, the red actually was right. Sorry about
It
that,
should
guys.
be -5, right?
Yeah.
Is that what it's saying?
Wait, what am I doing here? Yeah, should be -5. Yes. If it's even, they're gonna match.
Yeah.
If it's odd, they'll be opposite signs. So sorry about that, guys. I picked the wrong one when I was making this thing up.
Is that one not the right one? The yellow?
So the answer should be -5, 9. And oh,
Yeah, that's what it says.
oh, okay, good. Phew. Okay, I was just looking at it funny. Okay, good, good.
I think just a
Yeah,
lot of them
okay.
answered that one wrong.
Okay.
Okay.
Good. All right. Name some of the points needed to complete the graph if you want it to be odd. Okay, so most of y'all got that right. Good. Let's look at this. Okay, so if we look at the points that we have so far, we have 0, 0. We have 2, 2. And we have 3, 0. So if we go back here, -2, -3, we want this to be odd. So this would have to be the opposite. And this one would just stay 0 because 0 is neither positive nor negative. So if we were to plot -3, 0 and -2, -2, that would be what would give us the odd function. Which of these statements is false? Okay, so most of y'all got it. That's awesome. The zeros of a function are the same thing as the roots. So we talk about the roots, we're talking about the zeros. Same thing. Have we covered that, Matt? I'm not sure if we've covered that yet.
I think we called them zeros. I don't think we called them the roots yet.
Okay, okay.
That might be a new word.
So maybe that's not a fair question, but they are the same thing. So I always forget sometimes where the order where the vocab is in this section. All right, a relative extrema. The reason I put this one in here is because people go, what the heck is an extrema? An extrema is just the same thing as a max or a min. So anytime you see the word extrema, that means it's a maximum or a minimum. It might be either one. Okay, it's just another word for a local a maximum or a minimum. The endpoints of a graph can never be local. Local max, local min can never be the endpoints of a graph. Now the absolute max or min can be, but not local. And finally, all functions must have at least one max or at least one min, and that is not true because let's say you have something that looks like this. That doesn't have a maximum or a minimum. It just goes infinitely in both directions. For the following function, which of the following is true? That should be -7, -3. Sorry, guys. That should be -4, 5. Okay, so let's look at this. So the red one, graph has a local minimum of -3 and 0. And we're talking about maximums and minimums. We're only talking about the y value. It's how high or how low it goes, which is determined by the y. So local minimum of -3 and 0. Okay, so -3 is an endpoint, and you can never have a local on the end. Okay, local has to be inside somewhere, but not on the end. The blue one, graph has an absolute minimum of -3. This one, the graph continues to go lower and lower, even though it's not labeled, it is lower than here, right? So it goes to -infinity. And if you couldn't see the little arrow, because I think it might have been hard to see the little arrow on this. Oops. There's an arrow here, but even if you couldn't see the arrow, you can see that the graph goes below -3. The graph has a local maximums of 5 and 3. Let's see, where did my mirror go? So local maximum here is 5, and here is also 3, so that is true. A local maximum could also be an absolute maximum, because in this problem, the absolute maximum is 5, so that's true. And then the graph has 1, 0, and that's not true because there's a 0, crosses the x-axis, there is a 0, touches the x-axis, there's a 0, crosses the x-axis. So anywhere it crosses or touches the x-axis is considered a 0. For the graph below, identify the absolute max and the absolute min. Kind of all over the place here. So So this one does have an absolute min. This is the absolute bottom. You bottom out on this point. So the absolute minimum, and remember, absolute max and mins are always the y values. So the absolute minimum is negative 2.6. Now this 3.4 is a local maximum because in this little hump right here, it is the top. But for the graph in general, these guys keep going infinitely up and up and up. So there is no absolute max at all because the y values are going to infinity. Remember that absolute mins and maxes are always determined by the y value. They occur, we'll say the absolute max is like, in this case, it was negative 2.6, and it occurred at, so the absolute min is negative 2.6, and it occurred when x is 2.8. So that's how it's stated. Identify the local minimums and the absolute minimums of this graph. So good, most of y'all got this. Let's look at this. So we want the local and the absolute. Remember, local cannot be an endpoint. And maximum mins are always the y values. So the local minimum, the only place that we have a local minimum is right here, that's 7. And the absolute minimum is negative 42 because it is the absolute bottom. It bottoms out at negative 42. And you couldn't say that negative 42 is a local minimum because it's an endpoint. If it had been, if this had continued to go back up, then you could say it was. But since it's an endpoint, you cannot say that it is. Any questions on the Kahoot? So let's go ahead and look at the bookwork for tonight and see how far we can get on that. First, let me see who gets the most points. Yay, Timothy. Hey, Elliot. Awesome. And Hunter. Great, you guys. And Michael and Chris are runners up. Okay. Okay, so we're looking at, and I think I got lazy on this and didn't mark the ones that we're doing, but okay, so let's look at this. And it says use the graph to estimate the local extrema. Remember, local extrema means the local max and or min. There could be more than one. The absolute extrema is there's only exactly one, if any. And it's where the graph bottoms out or maxes out. And the local cannot be an endpoint. And when we're talking about these, we're talking about the Y values. Okay, so let's first talk about the locals. Where are the high points of this graph? Anybody? Approximately?
For maximums,
Let's look at, yeah, the maximums.
I have at 2 and about 26.
At 2 and about 26. Yeah, that looks good. So 26 would be one of the local maximums, right? So we have a local max at 26. And where else?
Then the other one is at -3 on the x-axis.
Okay.
And it is at about 18.
That looks good to me. All right, so another local max would be at 18 when x is -3. Okay, what about local min?
I've got the first one at x is equal to 3 and the y is about 24.
Looks good. So the local min would be at 24. And then
The other one is at -1 and the y is -10.
yeah. So the local mins are at 24 and at -10. And these are the valleys that you're looking at. Now, what about absolute? Are there any absolute extrema?
No, it looks like it keeps going in both directions.
Right, it keeps going in both directions, right? This one keeps going infinitely up. This one keeps going infinitely down. So that means that it never reaches an absolute high point or an absolute low point. So there are no absolute extrema. Okay, so the part A, the local maxes are 26 and 18, and the local mins are 24 and -10. And if you're asked where do they occur, then you want to name the x value. And then there are no absolute extrema. Okay, so 13. All right, how about 21? Michael, can you tell me?
Number 21.
Uh-huh.
Okay, so for A, now we're putting points here, not just the Y value, right?
Well, I like to name the point, but
Okay.
the actual answer is the Y value.
Actual, okay. So local max is going to be, well, there's two of them that look like they're even.
Yeah.
So I guess we can put both which I'm estimating this to be at, the first one would be at negative 1.5, positive 4.
Mm-hmm.
And then the other one would be 1.5, positive 4.
Okay.
Let me put that.
So what is the local max?
Well, there's, oh, okay, so the local max is positive 4. I was just
That's
giving you the
right.
2
The local
points.
max,
Yeah.
the absolute highest point on this graph is 4. It occurs
Yeah.
twice, but it's still the highest you can go.
Mhm.
All right, what about the local min?
And then, so that, there's only one, and that is at the origin, so that would be 0, 0, or just 0.
Right, the local min is just 0. What about the absolute max?
So we don't count local as max also, right? Because I mean, it's
You
all
can,
pointing
right.
downwards.
The absolute max is just the absolute highest you can possibly go.
Okay, so regardless of whether it's on the end or not, okay,
Right,
so-
and regardless of whether you've already counted it as a local.
right, so that would be 4 again.
That's
in that
right.
case. Yeah, and then the min is non-existent because it goes all the way
Right.
down. Yeah.
Because it just keeps going further and further and further down to hell. All right, so number 27. Chris, you think you could help me with this one?
I'll give it my best.
Okay,
It's been a minute since I did all these graph stuff.
that's okay. You're good.
Yeah, I was gonna say, like, in the notes, they don't actually give them a lot of. I don't think they give them any examples of multiple local mins or local max.
Oh,
It's just like they give them one local min or one local max, but you can have multiple, obviously, as you're seeing.
yeah,
But there is only one absolute, right?
right, right. Okay, so Chris, first of all, name some points for me. Just name some the tops and bottoms.
The tops and bottoms,
Approximate them.
like -3. Oh no, wait.
Yeah. What's this one approximately?
So -3, and I guess you could put -2, 0. So for the
So -3 looks like it's about what, -0.7 or something like that.
-0.7 or so.
Yeah.
And then for the second one right next to it, I'll put -2 point, I don't know, 5 or something.
Yeah, that's good.
Now for the other one, the highest. Oh, my bad, I didn't see that one. That won't be like -1 point, I guess, -5.
Yeah.
And for the highest one, it'll be probably -0.52.
Yep. And then
And
this
then-
one?
I'll say probably like -2. I mean, sorry, 2.5 to -2.
Okay. And
To finish it off, I'd say 3 to -1.5, I guess.
yeah, you could put -1 even if you wanted to. I don't care. -1.2 or whatever. Okay. All right. So let's talk about the local maxes first. So look at the high points, look at the Y values, and look at the high points. Look at the Y values and look at like if they're at the top of a mountain. What are the peaks? What do you think, Chris?
The what now?
What are the Y values of the top points?
2.
2 is one of them. And there's another peak.
Oh, 2, and I'll probably say the one where it says 0.5, I guess.
0.5, right. So those are our local maximums, okay? Is there an absolute max? Is there one that's higher than any of the others?
Yeah, I would say the one that's on the 2. 'Cause that's like the highest one I can see.
Right. So the absolute highest point is 2. All right, now let's look at the local mins. Okay. So name some local mins, the low points on the graph.
Low points. All right, Gigi. Low points would be where it says -3 at -0.7.
Okay, and that one is a low point, but it's also an endpoint, right?
Mhm.
So an endpoint can never be a local.
Oh, so endpoint. Okay, so it's got to be in between the 2 points on the
Right.
RG. So I would guess the alternative besides that one, since you can't use the endpoint, would be -0.5.
-0.5, and what else?
-2.
-2. Okay.
You can't use -1.2 because, like I said, that's an endpoint.
Yeah, you can't use an endpoint for a local. Okay, so what about the absolute max? What's the absolute lowest you can go
Lowest
on
would be
this?
-2.
-2, right?
So basically, anything that's in between the points of the sides of the graph, you can use it, just not those points.
Right, for the local, right? And absolute can be any of the points.
So basically, max means the highest, min means the lowest, basically.
Right, max is the high and min is the low, right?
Alrighty.
And extrema, when they use the word extrema, that could be either one. It could be either a max or a min.
All right, sounds good.
Okay, so this one, first of all, can anyone tell me, and I'm really hoping you can, what this graph looks like? What's the general shape of this graph?
Parabola.
It's a parabola. And the parent function of a parabola looks like this, right? This is the parent. And this one is doing what? What's happening to this parabola?
Shifts up 1 unit. on
Shifted
the
up
y-axis.
1, right? So this is a parabola that shifted up 1. Okay, so I'm gonna erase this. Okay. So they're saying local extrema. Local extrema means, does it have a local max or does it have a local min? And what is it? Timothy, can you help me?
Well, since they're all going up to infinity, there really is no local.
Is there is there an absolute max or min?
Well, the absolute minimum would be 1, but there is no maximum because they're both.
Right, so the absolute minimum is 1, right? So the absolute minimum is the number 1, right? Is 1. That's the lowest you can go on this graph. So that's also going to be a local minimum. Okay, if it's an absolute min, it's also considered a local min. Okay.
Okay.
Is there any absolute or max or local max?
No.
No, because it just keeps going to infinity, right? Keeps going up and up and up.
Yeah. Yeah.
Okay. Okay, so use this graph to determine if the function is even, odd, or neither. Gabby, can you tell me?
I think it's neither
It is neither. Why?
because it's not touching the x-axis.
It
all the way.
it doesn't touch the origin, right? It's not crossing the origin. And it's not symmetric to the y-axis, right? And it's also not symmetric to the origin. Thanks, Gabby. Olivia, what about 57? What do you think?
I think it's odd.
Yes, good. Okay, great. It's odd. It's anytime it has like that kind of like an S shape, curvy shape, and it has for it to be odd, one part's going up, one part's going down, passes through the origin. And has origin symmetry, which means that if you rotated it 180 degrees, it would come back on top of itself. Okay, we're going to do all of these just because it's fun. So, Elliot, can you tell me 59 and 60, are they even or odd or neither?
They are odd.
Good. They are odd. These are all polynomials. So we can basically just look at the exponents. Both of these have just one odd exponent, so they are both odd. And just for fun, what kind of graphs are those? What would they graph to be? What would the general shape of those be? Anyone?
Line, right?
Yeah, right. Okay. Bree? What about 61 and 62? What do you think they are? What did you say?
Are they even?
Look at the exponents. What's the exponent? Even though it's not written. If the exponent is odd and it's a polynomial, then it will be odd unless we've got here, a constant always counts as an even, right? So here
Yeah.
we've got x to the first plus 3x to the 0, 2x to the first minus 1x to the 0. So the exponents are mixed, a mixed bag. You've got some
So
odd
it'd
and
be
some
neither.
neither, exactly.
Okay.
What would these two graph to be if you were to graph them? What would they look like? Mx plus b. What equation that? Y equals mx plus b. What is that the equation of? A line, a parabola, an absolute value. What do you think?
I don't know.
I'm putting you on the spot. I'm sorry. So if it's y equals mx plus b, it's always going to be a line.
Okay.
I think you know that. I'm making you nervous. All right. So Monica, are you there?
Yeah, I'm here.
Okay, great. What about 63 and 64? What would they be?
64. Would it be even?
Yes. All right, remember that you were looking at exponents. Both of them have even exponents on the x. And if you've got a constant, then that's considered even because this would be like x to the 0 power. All right, what kind of graph, Monica, would those be? Your choices are a line, a parabola, a square root, or an absolute value.
A line?
Lines, remember, are first degree. If it's got a square on it, it's going to always be a quadratic or a parabola. Okay, so these would be parabolas.
Oh, yeah.
Okay, good. I know. I'm great. All right, 65. Letitia, are you here? August, are you here?
What's the intercept in 59 and 60? Because I think that's maybe a good point. Like we have two lines that are odd, and then we have two lines that aren't. Like,
oh, I like that. Yeah.
Yeah, what's
okay.
making them odd or not odd in this situation?
Mm-hmm.
So what's my intercept on like what, 59, 60?
Mm-hmm.
It's not there.
What is the y-intercept? Where does it cross through? What's the b on 59 and 60? Hunter?
50?
Yeah.
Wait, what do you say?
He said 0. The y-intercept is 0.
I said 50.
Yeah.
Oh, I thought you said 0. So if you graphed y equals 5x, that's like 5x plus 0, right?
Okay.
So yeah, so if there's no constant being added onto your linear function, then it passes through the origin. Whereas what about 61 and 62? Let me erase all this garbage right here. Oops. What's the y-intercept of 61? Where does it cross the y-axis? Anyone?
3?
Yeah.
Huh?
It crosses at 0, 3. So it's linear, but it doesn't pass through the origin, right? So that's why it's neither. And what's the y-intercept for 62?
-1.
Yeah.
It's not odd.
The picture I have in my brain is like 59 and 60 are like your little propeller. Like you're going right there in the origin, and you can spin that line any way you want as long as it's going through the origin, right?
Mm-hmm.
It's still going to be symmetric about that. But then when we start raising or lowering and putting a y-intercept in there, it's not going to keep that symmetry.
Right. So any line you have, if it passes through the origin, let's say we have this line.
Excuse me. Excuse me, Miss Watson.
Yeah.
My screen's frozen. I think if you're writing something, I can't see it. I'm on my screen. It says 62 neither. Y equals mx plus b.
Are there people?
You might like if you want to. Yeah, if he wants to log back in or something, maybe. I'm not sure what to tell him on that.
Yeah, Timothy, you want to log back in?
Sure, I'll try.
I'm sorry that happened.
It's all right. It's probably my end, low signal.
And we'll post these for sure. Okay, so these are if you have y equals mx plus 0. But if you've got y equals mx plus any b, that's going to shift it up or down, and so it's not going to pass through the origin. Okay. All right, what about number 65? Aurora?
Did you say Aurora?
What?
Was that my name?
Yeah, Aurora, I'm sorry, yes.
I want to say it's even.
Yeah, it is even. Good. Okay, and how can you tell it's even?
Because it's a polynomial and all the exponents are even.
Awesome. Yes, it's a polynomial. The exponents are even. This would be x to the 0. And you know what's fun? No, I know y'all are going to think this is so fun. Yes, sir. You know how a quadratic and x squared, the general shape of an x squared, like if you have y equals x squared, usually looks like this. Well, the general, if you've got an x to the 4th, if it's 4th degree, it usually looks like, well, what did I just do? Oops, sorry. Like a W. Now, sometimes, a lot of times, this piece will flatten out and it still looks like a U, just depending. But if it's 4th degree, you can get like a W. And if it's 6th degree, like this one, then just add another hump. So that's kind of fun, I think. Okay, so let's go back here. So we said that 65 is even. Aurora, what about 66?
That also even?
That is also even, right? And why?
The exponents are even numbers.
What are all the exponents here? And it's a polynomial.
6 and 2.
Right, the exponents are all even, so it is even. All right. Hunter, how about 67?
67 is odd.
Odd. And why?
All the exponents are odd.
All the exponents are odd. It's polynomial. All the exponents are odd. Okay, how about 68? Hunter, I'm going to hang with you.
Also odd.
Also odd.
10.
And what about 69?
Neither.
Neither. Right, neither, because you've got an even and an odd exponent.
So I mentioned it in the notes, but we use the words even and odd a lot in this section. And they refer to the symmetry that we're talking about here. In the next section, we're going to call these things, we're going to use it, talk about a different concept called even degree function. So if I use the word degree, it means something completely different.
Yeah.
Don't get these two concepts mixed up.
That is such a good point. That is such a good point. So we'll emphasize that. Yes, we will emphasize that, because an even degree function can have both even and odd exponents in it. So
yeah, when I use the degree, I'm talking about the highest degree there is what I'm talking about.
Right, and we'll get into that. All right, it's 10:20, and we are spreading this out over 3 days, so I think we can stop. Is that okay with you, Matt, if we stop here?
That's fine.
And Matt will pick it up tomorrow, and then I'll finish out everything that we on Thursday. Okay, y'all have a wonderful day. If you didn't vote, go vote.
So we turn this homework into.
Bye, thank you.
Bye, you guys.
So we submit this homework today, right?
No,
Tomorrow.
you can submit it tomorrow.
Oh.
Yeah.
Oh yeah.
Yeah.
So
We'll finish it
so
up
we'll
tomorrow.
go over some more of this. Okay.
Yeah,
Thank you. right, thank you. Have a
Matt,
nice evening.
I want to talk to you for just a second when everyone's off.